Hey nerds, we're hanging out with some standard form today. So at the top of your notes you can put U2 for standard form of linear equations, and it looks like this. Um, we've seen in the past y equals mx plus c. That's slope-intercept because it has the slope, and it also has the y-intercept. We're going to look at the standard form, also called the general form if you're British, and it looks a little different. It looks like this. So that's some number times x plus some other number times y equals c. This c is a capital C, and this is a lowercase c. So these are not the same. Just want to be careful about that. These are not the same C's. This is a lowercase and this is a capital, and they mean sort of different things often. So let's jump in. This is what standard form looks like. We can change slope-intercept to standard, but we'll do that next time. I want to show you why you might use it, and then we'll break down what the equation kind of means. Okay. So do write this in your notes. Maybe pause me until then, but we're going to look at 3 examples, and hopefully that'll clear up what all this stuff means. Okay, so the idea is that this is an equation in standard form. You have some number times x plus some number times y, and that always is equal to a constant value. So if we were to graph this, it would look like this. Now, what's nice about standard form is it lets us find these points really easily. And so I want to look at 3 examples about how to use this, and then I think it'll clarify what all the pieces mean. So let's just try it out. So you have 12 bucks or 12 francs or whatever, and you've been sent loose to ravage a candy store to get your sugar fix. Your faves are bags of extra chocolate crunchy pops, and also bags of yellow sour gummy bears, right? X and yellow, right? These are $2 a piece, and these are $4 a piece. So you're about to go atomic. The possibilities are endless, sort of endless. What we want to do is look at what are the possibilities, because you sort of have integer numbers that you can buy. So let's think about on the yellow side. We'll go with something yellowish. So for this one, what's the maximum number of bags of yellow sour gummy nerds that you can buy with your $12? Pause me and think about that. What's the most if you just bought yellow and yellow sour gummy nerds and no extra chocolatey? How many you could buy? Pause me and think about that. All right, so the yellow sour gummy nerds are $4 a pop. So if you have $12 and you divide it by those $4 each, you can buy 3 packets of those, right? But that means you buy so 3 yellows, and also that means you buy zero chocolate guys, right? Because each one of these is $4, so your $12 is all used up. So we're going to represent that here. This is like, this X is the number of extra chocolate gummy crunchy pops you can buy, and if you buy 0 of those, 0 over, then you can buy 3 of these, 3 up, right? So this is no chocolate guys, but 3 of the yellow guys, right? I'm going to put those in parentheses, and that's a coordinate. Okay, we're going to think about how many of the extra chocolate country pops you can buy if you buy no yellow sour guys. So think about that. All right, if we have $12, the extra chocolate crunchy pops cost $2. How many of those can we buy? Well, the 12 divided by 2, we can buy 6 packets of the extra chocolate. But that means that we have to buy 0 of the yellows, right? So we can represent that point here, right? We buy 1, 2, 3, 4, 5, 6. Here there's 6, but we're not going up because we've not bought any of those. All right, great. So this is 6 of those, but we can't buy any of those because of the chocolate guys, we've spent all our money. So that's another point. What I'd like you to think about is figure out a combination of being able to buy some of these and some of those, breaking even with $12. You've spent all your 12, some of the extras, some of the yellows. Bear in mind the yellows are $4 each and the chocolates are $2 each, and figure out a combination. Actually, there's 2 combinations that work really well. And pause me until you found them. Go. All right. One combination that might work is if you buy just one. If you buy one chocolate guy, those are $2 each, right? So I'm going to say 1 times 2, and also if we buy 2 of the, let's see, one of those, and no, that's not going to work. That's not going to work. I think we're going to have to buy 2 of them. If we buy 2 of these and 2 of these, if we buy 2 of each, that'll mean we've spent 4 on this. Oh, but these are $4 each. So I'm going to put 4 here instead of 2. Sorry, messed you up a little bit. And then it's $8 from the chocolate guys. So really we have 4 and 8. So that's 12. So that works. We've broken our bank, right? So one of the combinations is 2 of the $2 ones and 2 of the $4 ones. So 2 of those and 2 of those, and that works, right? And that was 2 and 2, right? And that's great. And another combination that might work is, I think, 4. Let's do it color coded. 4 of the $2 ones. All right, 4 of those, and so that'll be 8. And so I think you're only left over with being able to buy 1 of the $4 ones. So that's 8 and 4. So I think that'll work as well. Oops. So that's 8 and 4. That's also 12. So that would look like this. 4 of the $2 ones and 1 of the $4 ones. So that's our next spot. So that's 2 and, 4 and 1. All right. So all of those work to make $12, spending all of your $12. So if you take a look at those, they're all in this beautiful line. And that's really what an equation is. It's like all of these points on a line describe a situation. And so one way we can think about this is I want the number of X's, that Crunchy Pops, times the cost of them, right? Times the cost. Right? We multiplied those and we added it to the yellows and the cost of the yellows. Right? Might put cost of the yellow, and here put cost of the X, and that should be equal to the amount of money you have, which is $12, right? Well, we don't know X, we don't know Y. Those change, right? Those change as you go, but the costs are fixed. And how much was the cost of the extra chocolate? Well, it was 2. I'm going to switch places. So this is the 2. Here's the X. I'm going to write it as 2X, right? We added that to the cost of the Y, which was $4 each, right? So 4 times Y, so 4Y, and added up those should be 12, right? So this is our equation, and it's in standard form, right? $2 per chocolate, $4 per yellow gummy, and those should equal 12. And here are the possibilities: this point, this point, this point, and this point. Cool. Take a second, read this, try it out with the same way. I'll pop back on the next video and walk you through that. Cool? Go.